get into the big topic of open source, something that we actually say at Red Hat.
We haven't
This is so
we
awesome.
are an open culture that believes
actually
in
a big
importance of
piece
What is that process that a developer, or let's say a
As the
developer-
Kubernetes ecosystem really boomed,
Hello and welcome. How are you?
Hey Andrew, your audio it dipped out pretty bad. I don't know if it's just me that.
That's disappointing.
There it goes. Okay, it's better now.
Okay. Well,
All right, start over.
yeah. Well, hello and welcome. Thank you, co-host Jonny Rickard. Yeah, I don't know what's up with that. So you remember a few weeks ago, it would blip. My video would blip when we first started and stuff like that. I think I determined that. You remember when I was fiddling around with the Mac OS animations, when you do this and stuff like that?
Mm-hmm.
Since I turned that off, it stopped doing that. So I think it was just being glitchy and, So I missed the little animations. Yeah, it was a nice little way to punctuate points. If it was a little cheesy, I know a lot of people don't like it, but we have fun here as much as we can.
So do you know Anthony? Well, you know Anthony. Anthony on my team, Anthony Herr. He actually 3D printed the emoticons, so that way, if somebody's doing something, he's got it all wired up. So he'll just pull a string, and then the thumbs up will come down because he doesn't have a Mac. That's funny.
That's great. That's great. Yeah, it's Linux solves all the world's problems, right?
Indeed.
Well, thank you to our audience for joining us today. This is episode 125 already. Man, time gets away from us, Jonny. So this week we were going to be talking about API priority and fairness, and we are joined again by William Caban. William joined us a few episodes ago. I don't know, maybe 6 or 8 or 10. We went kind of in depth about etcd. Mm-hmm. It was a lot of fun. I know Jonny and I both enjoyed that stream because it was one of the more technical ones we've had in a good long while. And we're also joined by Abu. So I will ask you all to introduce yourselves, starting with William.
Sure thing. Hi, everyone, again. William Caban, one of the technical product managers here of the OpenShift core component.
Hey, everyone. My name is Abu Kashem. I'm an engineer with the control plane group at OpenShift.
Awesome. Yeah, and OpenShift core is this... it's a very broad, encompassing term that we use to refer to kind of everything Kubernetes inside of OpenShift. So you say that as though it's this little small thing, it's only the littlest part, but no, it's kind of the thing that underpins everything.
The everything.
So I will admit, I don't have a lot of knowledge around today's topic, the API priority and fairness. As I like to say, this means that I get to play the role I was born to play, which is dumb guy. So William, I don't know if you have, a 60-second introduction or preview of what we're going to be talking about today that you could share.
Yes, I can definitely talk on precisely. APF is one of those functionalities that is there, and Abu has been upstream leading the graduation of this. And it's so powerful, but still very few people understand, and even less people actually use it. And it helps in, for example, when you want to handle denial of service attack, for example, or what if you have your own applications interacting so much with that API that then the cluster cannot do its own work. So that is the area where APF, or API priority and fairness, comes into the table. Again, 10,000-foot view.
Got it. And I now have a tremendous number of questions that I'm going to get to. So, Frank, I see your question there. What is API priority? The literal interpretation is, basically assigning higher or lower priority to, I think, certain clients or maybe certain types of requests. I'll let Abu and William answer that here in a few minutes. So that, very much to your point, William, we can keep the control plane, we can keep the cluster operational, even if there's something that's banging up against it that's causing a lot of issues. So,
Yeah.
kind of an important thing.
Kind of.
So, I'm definitely looking forward to this. I think it's going to be a lot of fun, and it's something that I have seen some questions come up, coming from our field folks, which invariably come from customers around exactly how to protect against these things and all that. So I'm looking forward to it. So with that, this is just a reminder to the audience. This is an office hours live stream here on Red Hat live streaming, which means that we are here to answer any and all of your questions. So it doesn't matter if it's related to today's topic or not, anything that you'd like to ask us about OpenShift, we are happy to do our best to answer those questions. If we don't know the answer, which, Jonny's pretty smart, but he doesn't know everything yet, we're happy to dig back and ask all of the folks inside of engineering or the BU or wherever inside of Red Hat in order to get those answers. And when we do that, we can always share them back, and we'll all learn together, so to speak. You're also welcome to reach out to Jonny or I. So if you aren't listening to us live, I know a lot of folks don't watch us live, or they listen to us in the car, that type of stuff, almost like a podcast. You're more than welcome to reach out to us via email. If you're watching us, you can see them on screen. It's Sully, Sully, at redhat.com, or Jonny, Jonny, at redhat.com. And we love to get emails from folks, so please don't hesitate to reach out. How does someone remove the kubeadmin option at the login for the console? I think that's in documentation, Jonny?
Yep, it is. I'll find it.
Yeah, it's either in docs or in a KCS. Effectively, you want to create another user that has, cluster admin privileges and then remove kubeadmin. But I believe that also does not change certificate-based authentication. So if you have, if you accidentally remove kubeadmin without creating another cluster admin user, you would use the certificates that are generated when you originally did the cluster install to log in as an administrator and then create a new user as needed. There's also a way, and I think that one is in a KCS. Thank you, Jonny. To create new certificate-based logins for users. So, for example, if you wanted to also, remove that certificate-based login for the cluster administrator, you could do that, and then have those other cluster or certificate-based users. OpenShift documentation says monitoring with the integrated monitoring stack of user projects needs to be enabled manually. Yes, that is correct. When I view the project detail page, I'm able to see the resource utilization for a project.
And by the way, anything on OpenShift control plane, but specifically, for example, the API server, that's the guy.
Good use of the tiles there.
Exactly. So, yeah, any questions that you may have on that?
So from me, so user workload monitoring is specific to monitoring your applications in the cluster. So if you wanted to see, for example, resource utilization of the pods that are in that namespace, that's just a part of the normal cluster, monitoring that and collection that happens from Prometheus. When you have, Andrew's web application deployed inside of pods and I have a metrics endpoint exposed, basically I turn on user workload monitoring, I create an instance of the object, and this is all in the docs that says, go scrape metrics from, here, and then it ingests that into that separate Prometheus instance, and you can query that. You can deploy your own Grafana and create dashboards for your application, all those types of things. But yeah, the base level, CPU, memory, network, all the normal stuff that you would expect from a pod, that's all collected in the normal way. And I think if you want to see project level information like that, you have to go into one of the monitoring dashboards or observation dashboards and look inside of there. I haven't looked in a minute, so I don't know off the top of my head. All right, Jonny, do we have any top of mind topics this week?
The only one that I really had was the what to do with OpenShift 4.15. The video is out on YouTube now. I know that there were some audio issues, so I haven't actually gone back and watched this to make sure that that's fixed. But I assume since it's published that those have since been resolved. So here's the link to that.
Thank you. I was just going to go dig that up. And it has been fixed. I did check it. I submitted the request to the web team to have the What's New landing page updated. So I will share that link.
Awesome. But yeah, I think that's, I mean, other than the, I guess I can go over the schedule. So next week we're going to have we're going to do the intro to network observability operator. And then March, we're going to have our AI series. So we're going to managing ML ops and managing ML ops with GitOps, predictive AI versus generative AI, and DevOps versus ML ops. So a bunch of awesome sessions coming up in March. So make sure you tune in.
Yeah, I'll not only plug all of the AI sessions that we've got going on, and I know that team is super busy. They just did a Red Hat 101 session with a couple thousand people here inside of Red Hat. That was it was pretty amazing. So I know that team is busy, but don't forget KubeCon is coming up. Red Hat, somebody told me yesterday, Red Hat has something like 60 sessions or 60 sessions that Red Hatters are participating in at KubeCon.
Wow.
Because, we're heavily involved upstream. I'm sure Abu and William can tell you far more about that than I can. So I know there's a bunch of sessions that we have there, booth, all that other stuff. There's several people from my team that will be there. Commons is a day zero event. You can go. I want to say they're doing multiple workshops, including they tagged me about an OpenShift virtualization workshop. I will not be in Paris, but
that's too bad.
So yeah, lots of stuff going on there.
Yeah,
and go ahead.
I'll be in Paris, and I will talk about APA priority and fairness as well. So you're welcome to join us there.
Yeah, come by, get an autograph from Abu. Yeah, that'd be awesome. Pictures and autographs.
Yeah, see now the audience gets a preview, so they can stage super hard questions to come in and ask you, or
that's right,
or maybe really easy questions to make when you're on stage make you shine. What was I going to say? Oh, Summit. Also, so Summit, I believe the catalog should be published soon, within the next couple of weeks. So they did send out all of the sessions and lab acceptances and all that other stuff. And I know that February 16th was the date that I kept getting harassed about to have my abstract updated and my bio updated and my speaker photo and all that other stuff in there. So that usually means that they're very close to publishing the catalog. So keep an eye on summit.redhat.com for information on that. That is the second week of May, I think. Or the first full week of May, I should say, in Denver. So new city. I'm excited about, new city for the conference. I've been to Denver before.
Mm-hmm.
So I'm excited about that. It's not Boston. It's not Las Vegas. It's not San Francisco. It's not Orlando. It's not Dallas. The normal set of North American conference cities. So I'm happy about that.
A lot of microbreweries there too. It's a good beer.
Yeah.
Oh, sorry, Willie.
No, that one of the things, for example, I know that travel restrictions still widely common. Let's say, don't forget the Kubernetes community days. I know because, for example, the KCD here in DC, there's one. It's already published. In New York, Texas, when it's North America, I know, for example, the ones Mexico, Guatemala, Costa Rica, Colombia. So it's another venue where we can be part of the community, and it's more localized, so we don't need to necessarily travel international.
Yeah, I know between the Kubernetes community and the Red Hat community, so the Red Hat user groups and stuff like that, I think most of the major cities are covered these days. So, yeah. Thank you for sharing those, Jonny.
Yep.
I think there's a KCD this weekend down in Buenos Aires. I say that because I remember one of our speakers for one of the BU sessions was saying that he's sticking around through the weekend to present down there. So,
nice.
Yeah. Let's see. Right, yeah, I think that was all I got. If for anybody who went to Summit last year, we're still evaluating what's going to go on in the booth, but I'm hoping to have more technical, people power in the booth. So I'm looking forward to that, Jonny. We may get tapped. You and I may be tapped to be. I'm going to say pretty booth faces.
Yes.
Which is it's a sad state of affairs when they're tapping into us, but. No, they asked me about using, Ask an OpenShift admin as like one of the brands inside of the booth. And like, well, one, I would love for that. Clearly I'm attached to Ask an OpenShift admin, but do we want to limit our audience, to just administrators when OpenShift has, broad appeal and stuff like that? So it may be Ask an OpenShift expert or something like that. But I'm looking forward to it. I think it's going to be a lot of fun.
Yeah, that's awesome. Let me know. I'm down. Maybe.
Yeah.
Definitely maybe.
Just hitchhike up to Denver. You'll be fine.
I should. It's not that far.
All right. So that's all. I think that's all we've got. We went over the schedule, talked about a couple of things. Yeah. All right. So let's talk about API priority and fairness. And William, as you said before, this is really focused around basically mechanisms in the API server, I believe, that help to, as the name implies, provide priority to certain requests as well as fairness to overall clients. And like to me, this sparks a whole bunch of questions. So things like, we know that using Argo CD, for example, sets up a bunch of watchers, and watchers, I think watchers are within the API server themselves and pushing out information, not the other way around. So, that when we have a bunch of watchers, not just Argo, but other things, other operators that are happening, how does it affect that and all that? But I'm sure I'm getting ahead of myself. So I will trust you all and say, please educate me.
Sure. So let's by the way, on the watcher, in addition to the API priority and fairness, something that is being worked is also the API streaming. I think I mentioned the other time, and that will have a significant impact, improving the performance overall of having huge amount of watchers in the system.
Is that like a pub sub type of architecture instead of a push, or?
It's mostly like today when you do a list request, like you're getting a number of objects from the API server, right? We try to send them all at one time. So instead, I think we're moving to like a new streaming architecture. So this is more memory efficient. So what we have seen in the past is that with big request, like this request that takes a lot of objects, the memory, the Go runtime is basically allocates a lot of memories abruptly. But with the streaming, I think it's more gradual. So it performs very well when you have like a lot of watchers. So I think Lukash is working on that upstream, and I think we're hoping that soon it will go into beta.
Yeah, I know I've seen or started to see more folks who have, and I've been saying this for years, right, William? You've probably seen me say it internally of, it's not just the size of the cluster, right? The number of nodes or even the number of pods in your cluster that determine how busy the API server is and how much resources your control plane needs. And I think we're starting to see folks that have, what I'm going to call smaller clusters, 6, 8, 10 nodes, where they deployed with the default control plane size, 4 CPUs, 16 gigabytes, not megabytes. This is not the 1980s. Gigabytes of memory, and they're encountering issues. And if you look in the docs, it says, with like less than 100 nodes or something, you only need 4 CPUs and 16 gigabytes of memory. And
that's the minimum for it to work, not for it to be a production with your use cases.
Exactly.
So that's the caveat on that one. That's the minimum just to make it happen. But
exactly.
Once you start adding, absolutely, based on the use case. And when I say the use case is, for example, GitOps is one that needs to be listing resources on very regular basis. So imagine you have, 10,000 pods, and you are actually looking at those pods. Imagine you listing 10,000 objects and all the properties and having to create that reply in memory first, and then send that to, let's say, the Argo client. So all that memory allocation, that is the type of use cases where the API streaming will help. because instead of having to allocate, I don't know, 80 gig to answer, you only have certain amount that you will just use but stream from there. That's one part. And the other is, again, with something like the watchers and all of those, if you don't have the APF, there are circumstances where you are creating denial of service attack against the API server if you don't have that properly set up. So
yeah, I mean, to give like a critical example of how APF can help, like recently we have run into a situation where we saw like cluster degradation, and after debugging we found out that some component in the cluster was trying to list all the pods in the cluster, and it went into a hot loop, and it was doing it very frequently, and that was enough to bring the whole cluster down, right? So I think that's exactly why we built like APF private and fairness to kind of as a self-protection mechanism for the API server, so it can protect the cluster when some rogue elements flood the API server with a lot of requests. Right? So it basically, classifying those requests that are coming in, prioritizing them, and being fair when you schedule those requests for execution.
Yeah, when Andrew was mentioning the it's more than just getting OpenShift installed and just the API. I remember William going over this when we were talking about etcd, about how like Argo just it's a constant like, hey, what's going on, and it's pulling up and then like it's just caching all this stuff. And so yeah, I could definitely see where like what Andrew's saying, it totally comes into play right there, because it's like you've got this controller out there and it's going out and it's listing all these resources, and if there's no way to kind of like, hey, pump the brakes, kid, and set it to the side and I can see how it could be a really noisy neighbor especially at the control plane level.
Exactly.
Yeah. And just to answer your question real quick, so yes, there is known issues with plugin caching in 4.14. So I linked a KCS article there that has some details. It should be fixed in one of the Z streams. I want to say 4.14.10, but don't hold me to that. So if it's not already fixed, it should be soon. But they're definitely aware of it. Usually what I do is either open an incognito window, or like on my Mac, I do a shift refresh to force it. And sometimes it takes 2 or 3 times to get there. Alternatively, you can go in and clear out cookies and cache and all that and reopen it, and it'll be that way, or it'll fix itself temporarily. But yeah, definitely a known issue. Definitely a little bit frustrating as you add more and more plugins. I have a cluster right now that has monitoring and ODF and OpenShift virtualization and several other things inside of there, and they all just disappear every once in a while. And yeah.
Well, I was not aware of that one.
Yeah. When you have something as big and as complex as, let's ignore Kubernetes, OpenShift and all the different projects that make up OpenShift, there's always something, right?
Yeah. It's just, I still, at the end of the day, it's a JavaScript somewhere. So when I still like see all these things these days, and it's a JavaScript somewhere in the UI, not doing what it's supposed to be doing.
Runs the world.
Yeah.
Or the web world, anyways.
Exactly.
I still get a kick out of. There used to be I'd say viral video, but it was a well-known video amongst all of us nerds of. It was a guy giving a presentation about JavaScript and some of the quirks that it has. Where you can add together, like literally add together a string and a number and get something. But if you add together like 2 numbers, it comes back with, or 2 numbers in quotes, it comes back with something different. Like it's just JavaScript is an interesting language.
Yes.
So never.
Okay.
So go ahead.
We go and do a deeper dive now on
Yes, please.
API priority and fairness, at least the core concepts. And I let Abu, who's one of the authors.
Sure. I have a slide deck that is a little outdated, but I can share it and I can start from there, and I can kind of try to describe why we need it and how it works. Let me see if I can show on the screen.
And here's the thing, and this is backstory or behind the scenes. So think about, you have an API server and you are sending huge amount of traffic or transactions to it. What does that sound like? So think about the networking world. Isn't that similar to what in the networking world, what's the bottleneck and how having too many flows were affecting? So Abu was telling me the other day something about that. So Abu, what exactly, how networking basically solutions there inspired this?
Oh, yes. So I think I can get to the details a little later, but overall, I think high level, I think there is an algorithm for scheduling network packets. It's called fair queuing scheduling of network packets. I think there's a paper on it too. And we actually took that algorithm and then adapted it to apply to like a server-side requests in the API server, right? So that, I think that's how we implemented priority and fairness. I can go a little bit deeper when we talk about the priority.
I just have a question, and this is not related specifically to this feature, but I've been curious for a long time about like the bottom two bullets here, available since 1.18, which was 11 releases ago.
Yeah.
But it's still a V1 beta 1 API. Like what does that actually mean?
Sorry, let me. Oops. So it was in alpha in 1.18, and I think 1.29 we went to GA. So this is not updated, but I'll have to change the slide. But during 1.29 we took priority and fairness to stable to GA, but it started at 1.18 as alpha.
So within the context of not just Kubernetes but OpenShift, I think it's important to know that like the alpha, beta, GA is not necessarily as scary as you might expect. Because like Red Hat will sometimes choose to support alpha APIs. I'll say rarely. I think most of the time we wait for it to reach beta before we make it a supported feature. But even being beta is not necessarily a bad thing, right? Red Hat supports it. It's still a fully functional feature, right? That type of stuff. So I want to point that out of like, being beta doesn't mean that it means that it's incomplete, but not necessarily unstable or unsupported.
In fact, I think for priority and fairness, like given the significance of this feature, we actually enabled it for alpha in OpenShift, and beta features are usually enabled by default. So yes, I think you're right when you're saying like beta doesn't mean that it cannot be used right now. It's just the life, the evolution of a feature in Kubernetes, right? Usually, alpha is disabled by default, and given if we need, given the significance of the feature, if we need to, we sometimes enable alpha feature as well.
Got it. Yeah, I just didn't want people to look at APIs, not just this one, but just in general APIs in Kubernetes and think, oh, it's beta, I shouldn't be using it. And that's generally not the case. And it's like the fast release channel, right? The fast release channel is GA. It's fully supported, but for I'll say historical reasons, a lot of people shy away from it, even though you could argue that there's no reason to do that.
Mm-hmm.
Anyways, sorry for the distraction.
No worries. So yeah, I mean, so what is priority and fairness, right? So I think at a high level, it's a self-protection mechanism for the API server. For example, like we want to protect the cluster when there is a rogue operator or a component hitting the API server with the flood of requests, right? And that could cause the API server or the control plane in general to suffer like CPU overload or memory overload, right? And then the whole cluster kind of becomes unusable. But what if we could say, there are some cluster critical requests, for example, those literal actions and a kubelet sending requests to the API server. Those are kind of like, critical requests that can keep the cluster operational, right? Still degraded because, some components are hitting the API server with lots of requests, right? But how can we keep the cluster somewhat functional even though we are going through a phase of degradation, right? That's what I think priority and fairness tries to do. It tries to, it has two aspects, right? First, we need to understand the source of the request. We call this flow, right? What user the request belongs to. That way we can know the source of the request, and we can understand the criticality, right? If it's coming from kubelet versus it's coming from a cluster component, a customer workload, right? That is not as critical as as kubelet is, right? So first, I think is the first part of categorization of the request, right? And the second part is okay. Now we know we prioritize the request and then we schedule it for execution. And if the server is overloaded and there are lots of requests in flight, we need to choose. We know that we need to choose the one that are critical for execution and reject the ones that have lower priority, right? I think that's like at a high level how it works, and I can go into a little bit. I can go into more details. Initially, I think before priority and fairness, we had a concept called max in-flight filter. That was kind of the a simple mechanism for the protection for the API server. Basically, the way it works is there are two settings, two sovereign options in the API server. If you are an admin, you probably would be familiar with these options. I think they're called like max requests in flight and max mutating requests in flight. These two options, and an admin can actually configure those options when the API server starts. Yes, go ahead.
Sorry to interrupt. Just out of curiosity, what's the difference between a regular request and a mutating request?
Yes. So the regular requests or non-mutating requests are like, if you do a get or if you do a list, right? A watch is also a non-mutating request because it doesn't mutate any object in the API server, right? It's just retrieving a set of objects for you. And mutating requests are if you are creating an object or you are updating or you are deleting, right? Those are we called mutating because it's actually mutating the state of the storage, right? So, and you could deal with them separately via these two server options. And it was the implementation was very simple in ways that we have to talk about like the terms, the concurrency, and how many requests enter or leave the API server per second, right? So concurrency is basically, so we have, let's take one API server instance, right? And n number of components are sending API requests to the server. So at any moment, or at any instance, the API server has, let's say, n requests in flight, right? Some of the requests just have arrived at the API server, but it hasn't started actually executing them yet, right? And some of the requests are actually being executed right now, right? So requests that are waiting, right? Requests that are being served, right? So we're saying that the requests that are being served are kind of limited by these two options. If we see the number of requests that are executing, the number of mutating requests that are executing, like surpass the value in max mutating requests in flight, we'll say, okay, we'll not take any more, reject it. Send it like a status code, SATP status code like 429. This has a significance on the client side. Client knows that 429 means too many requests and it needs to retry later, right? So client, we have built client Go in a way that when it receives a 429 status code from the API server, it automatically will do a retry after waiting for some time. So that's kind of the simple implementation of what we had before, and we called it max in flight filter. And it treated this basically, it's very coerced, right? Okay, we allow n number of mutating requests that will be served, and we allow n number of non-mutating requests at any time. But it didn't basically try to understand, like, is this request coming from kubelet? Should we try to prioritize it over other requests? It didn't have any logic built in for that. So that's when I think we decided, okay, we need to like APF, what it does, right? Basically replace the max in-flight filter with a version that actually can categorize a request and then schedule it for execution based on the priority. I will stop there if you have any questions.
Well, and I just wanted to point out, mutating requests are more resource intensive because the expectation is basically something is going to be continuing to update it, update the status field as things are changing with it. There's other things that it's going to, for lack of a better term, fan out and affect. So a mutating request is not just one request, it's expected to have multiple after that, whereas a regular request is just show me all of these objects type of thing.
Yes, and regular requests, and especially list, can be more expensive too, because if we have a list that requests all the secrets from that are basically from the cluster, right? There will be a lot of secret objects, and we have to serialize this object and deserialize, right? And that is also a very memory intensive operation, right? Also CPU intensive too, and that could be expensive too.
Got it.
So at the end of the day, it's the write or the read does not make the action expensive. It's what's happening behind the scenes with it. So an update on a single field versus the example there, like an actual request that we have to go inspect every object and get the information.
Yeah,
that's very resource intensive.
Yeah, and one example is, let's say you are getting a config map, and the data is like, let's say 50 megabyte in size, right? Versus you are listing 100 config maps, and each of them has 1 kilobyte of data size, right? So I think there's a good example of it. Like it's very challenging to estimate the cost of a request accurately, because you let's say one request that takes 2 seconds to complete. That means it enters the API server, it stays in the execution phase for 2 seconds, right? Another request could be spending 4 seconds, but it could be that the one that stays for 2 seconds may be more expensive depending on what it does for the 2 seconds, right? Because the one that's waiting for 4 seconds could be just sleeping or just waiting for a simple I/O, versus the one that's spending 2 seconds but is doing a lot of CPU and memory intensive operations, right? Going back to the concurrency, right? So you see, this diagram shows very roughly that if you have any requests that are resident in the API server right now, and we have already exceeded the limit for max in flight, either for mutating or non-mutating, now those requests that are coming to be served, we'll be rejecting them because we don't have any more space, or like we have already exceeded the threshold.
And to be clear, this is before APF. This was the behavior. So it's from the networking world, you'll see similar graph when you do rate limit. When you do rate limit, everyone can talk, but I'm not differentiating after. That. So that's what's happening here as well.
Exactly. I think in the network world, they do bit by bit round robin. So you have a network, you have different network packets, right? Each of different size, and that determines the cost, right? So a network packet could be the size. So what the algorithm does is basically it simulates a bit by bit scheduling, in theory, and then tries to schedule it based on its cost, right? And the cost is determined by the size of the packet. But we have a more complicated problem in priority and fairness. How do you estimate the size of request before you schedule it, right? and so we try to guess. That's why it becomes like it's not always like 100% accurate, right?
I hadn't even thought about that. Yeah, because how do you know ahead of time that this config map, like you said before, it's a 50 megabyte config map? How do I know ahead of time that one's going to consume a huge amount of resources versus one that's 1 kilobyte?
Yep. Yeah. So I think going back, so this is at a high level what priority and fairness does, right? I think the first phase is classification of incoming requests, right? And like we call it flow, right? And we have a matching APIs for that. It's called flow schema. So today in your cluster, if you do OC get flow schemas, you will see a list of flow schemas that actually ship with a default cluster. And those try to match requests to a flow. So for example, we want to isolate all requests from kubelet, right? Or node health or health probes, right? And we want to make sure that those requests do not suffer, even if, and we can schedule them even if the cluster is degraded, right? So that is the first part. Classifies the incoming request into a flow, and then we can comes the next part is kind of the prioritization. So how do we do? I can talk about it a little bit more on the flow management. So it has if you look at the flow schema API, there is a section called rules, and there you can say, okay, any request that has this user matches this flow schema, or matches this flow. Any request having this resource URL or non-resource URL matches this flow. So we provide a more generic way for the admins to say, okay, I want to categorize or classify requests that are coming from my component, right? So this is API based, it's configurable. It's an object like a config map, right? So you can actually create new flow schema for your own component if you want to, right? But priority and fairness, it ships with a set of flow schema and priority level objects by default. We call them the bootstrap objects because these are the ones that we define for example, kubelet, node health, literal actions, right? For the critical components.
I mean, I have to say, I have a cluster. I just did the OC get flow schema.
Yes.
I didn't know that any of that existed. My mind is completely blown right now
Same.
And even expanding one and looking at it and seeing, exactly what you're saying of it matches the different rules for the endpoints and what, users, I never knew any of this existed inside of the cluster.
Yes, and this is it's an API, and a cluster admin can actually go and add new flow schema if you want to, right?
Yeah.
To categorize or to classify the requests for their own workload, right?
Yeah, and I'll take over the screen share real quick and show everybody. So you don't need to do anything, Abu. I'll just turn it off.
Okay.
So while I'm switching over here, so Yasser asks about how many requests an application server can handle at a time, and is there a maximum, and what's the default?
Yeah, so I think the maximum today is, so the way APF has been working is we did not. So if I go back to the slide, I don't know if we're. So these two options that were part of the max inflight filter, we have not removed them. They're still there. So what we do today is we basically sum them up, and that's what we call the overall server concurrency limit. Basically, we're saying that we will not allow we'll not allow the concurrent number of concurrent requests to be more than that.
And I think the first question there, which is how many can it handle at a time, there's not going to be a single set number because it's going to be based off of what those requests are, how resource intensive is each request, and the resources available to the API server. So to pick a kind of crude example, imagine using a CPU from 8 years ago versus a CPU from now, right? One for one, the newer CPU is clearly going to be able to accomplish more work. So even if it's the exact same OpenShift cluster layout or geometry with the exact same workload, one of those is going to be able to handle more requests than the other. Why can't we have any odd number of control plane nodes? So I'll toss that one over to you, William.
We actually can, with many caveats. Okay, so it's more about the caveats and what you are willing to call HA or not. Okay, so there's nothing stopping you from having one or having two. There's no difference on the HA level between one or two. So you are not gaining HA on that. Once you go into three, then since you have, again, a way to break the quorum. Thank you. The quorum. The quorum. Now you can, even if you lose one, you still have a majority to say, oh, this is the truth here. So it's more about that aspect. Okay, but yeah, there's nothing that will stop you from having 1, 2, 3. Is again, do you want a HA or not a HA? And if it's not HA, there's really no difference between 1 or 2. It's just more problematic handling the cases or the recovery. So to 1. And if you want HA, it's 3. After that, we'll go back to the HCD live stream, and we went really deep into those on the whys.
Yeah, I think it's important to point out, Red Hat supports either 1, so single node OpenShift, or 3, compact cluster, or really any other cluster. And, the reason for that is, like you said, HA. Because with 3 nodes, we can lose 1 node and still maintain quorum and still have the control plane be functional. Once you get up to 4, well, 4 doesn't add any additional availability. 5 does potentially, but now to your point, William, you're encountering, because etcd is larger, there's more latency, there's more operations, and so you end up limiting scalability because of additional etcd that has to happen and all this other stuff. So at that point, you're trading potential high availability for performance and scalability of the control plane. Yes. And so when OpenShift 4 happened, 5 years ago now, 4 years ago now, 4 years and change, the decision was 3 nodes. There will always only be 3 etcd, 3 control plane nodes, even though I know that there has been some talk of doing things like having, I don't remember if it was you, William, that was talking to me about this, or maybe, gosh, now I don't remember the other.
The scaling for 4 until...
Yeah, basically having non-participating control.
Oh, yes. We talk about that in the live stream. Yes.
Yeah. So technically possible, not supported.
Exactly. And if people go into the weeds of this part, you will probably realize that when you're doing, for example, OpenShift installation, and let's say you're using the assisted installer online, okay, you boot that node, a single node, and that install everything else. If you go very under the hood, you will see that during the installation, it goes from 1, and then it goes immediately into 2, and it complete install having only 2 control planes active. And then it adds the one that you originally booted as a control plane node. So yeah, it does work. We take the risk there, but it's not something that we can support. And it will just bring more problems than not. Okay, so
I think that might be a change from the way it originally was, because I thought originally it started at 1 and then went up to 3 or 4 and then reduced down to 3, and now
yes. So it depends on if you are using the assisted installer, which has that technique, versus the traditional one, which use the bootstrap node, and then so that one is 1, 3, and then move. So it's there's a different, but that's why I say, like, if you really look into on the hood what's happening, you will see that we can do 2. It's just, again, we cannot afford to support that.
And then, so real quick, I want to get Abu back to talking. I'll just show you here in my cluster here. So all I did was OC get flow schema, and you see it came back with this whole list of things, conveniently prioritized by precedence. Again, I had no idea that any of this existed, and you can see this is clearly a default. Like down here we have catch-all, which I'm assuming is anything not included up above. But like here's OpenShift SDN making a request, system nodes, kube scheduler, and if we look at any of these, so I just did a OC get flow schema probes, so this one, and then output is YAML, and we can see exactly what it's doing, right? So when it's matching, or sorry, not matching these URLs, I think, with the get verb, I don't know. I'll let you. You know what I'm looking at. I'm guessing.
Yeah. So this is the health probes coming from Kubernetes, right? So Kubernetes health probes are anonymous, so they're not authenticated, right? So you can see the subjects, the groups is system unauthenticated, right? And the resource URLs, non-resource URLs are like /healthz or /readyz/livez. So any health probes, we're trying to categorize all the health probes that are coming to the API server, right? That's the first step. And then what should you do with the health probes? And health probes are kind of very critical, right? Especially those that are coming from Kubernetes, right? So we want to make sure that even if the cluster is degraded, those requests should be scheduled. They should have a path to be served, right? And that's why if you look at so we talked about the schema flow, right? So there is a number of flow schema objects in the cluster. When a request comes in, what the API server does is go through the flow schemas in the order by precedence, which you can define in the object, right? So, and then finds the one that matches first. And the first match is basically we're saying, okay, this request belongs to this flow schema, right? So let's say a health probe, the Kubernetes sends a health probe, right? We go through all the flow schemas we have, iterate through them, and find the matching one. We'll find this one. This one will match, and then we'll say, oh, okay, this request belongs to what is the name of the flow schema? I forgot. Probes, right? And the next step is okay. So each flow schema object is linked to one and only one priority level. So what is a priority level? It's another APIs. And if you do like OC get priority level configurations, you'll see a number of priority level configuration objects we have. So each flow schema must be mapped to exactly one priority level. What the priority level does is it's used for the request scheduling, right? So once we categorize a request, now it's time for scheduling it for execution, right? And some requests might have to wait for before it gets executed, right? So as soon as we say the word wait, it means, okay, we have to put them in some queues. Otherwise, where would they stay until they're executed, right? So the priority level, or you could say, okay, no queuing, right? We either execute it or reject it immediately. As soon as we see it, we decide whether you want to execute the request, or if you cannot execute it right now, then you reject it. Right, that's the flow. Or if you think if the priority level says no, we should it uses queuing, then you can say, okay, we cannot execute it now. Let's put it to the queue first, and then scheduler will find the right time when it will execute it. Right. So the scheduler actually is basically goes through the priority levels and see which request it should execute now, and then pops it off the queue, and then actually executes the request.
Sorry, I'm looking at what it reports back for the different objects. Well, maybe.
So is this something that you see, like this would be a power user type of config, right? Or are these the type of things that like they're there and we as cluster admins, we shouldn't really mess with them? right? Or like we shouldn't really have to create these things. Like, is there ultimately? I guess what I'm trying to get to is like, is there one of these things that we could create that would, I can see where it can make our system unstable, but like make it unsupportable.
Yes. So a default cluster would come with the APF flow schema and priority that ships with it, right? I mentioned about like the bootstrap objects that are created for the cluster, right? And then OpenShift, for OpenShift, we also added our own flow schemas to like isolate the OpenShift SDN requests, right? Or we have a set of operators for a control plane, and we want our control plane operators to work once the cluster is degraded, right? So we have set of flow schemas that basically classify requests coming from SDN or our controllers, right? And then give them a dedicated priority level so that they can be executed in an isolation, even if the cluster is degraded. But yeah, so if it's a power user like configuration, I don't expect like everyday cluster like operator would be dealing with flow schemas or priority levels. If you are if you are Red Hat, or if you are like Google, like of course you want to customize your cluster so that your the control plane components plus the components that you provide, right, are actually can work as expected.
Gotcha.
And to add to that, think about this. So we have the ones that we have work upstream plus the one downstream. They are very tuned such that it works and protects the system. Now, when trying to create, if you are adventurous enough to go and try to create one of this, think about the implications. And it's not just the requests that you're seeing initially, but think about those type of requests that arrive, but then they generate requests. So that means that new request, you have to figure out that need to maintain at least the same priority, or if not, yourself, you'll be creating a problem for you.
Yeah. It's not to say that. So, for example, if you are an OpenShift user, right, and you have a workload that is very buggy, or it sends a lot of requests sometimes, right? So you could theoretically create a flow schema to isolate the request coming from that component, and give it like a low priority level, so that even if it sends a lot of requests to the API server, but it's going to that priority level, and that priority level has only like a small amount of share. So you can that way you can still kind of say, okay, if this operator or component goes rogue, we have a you can jail it to that priority level, right? So, and thus kind of preventing cluster degradation.
So is there, and this is my security paranoia brain kicking in, right? Like, is there a concern or anything like that where somebody, maybe they got cluster admin privileges, right? Like, could they weaponize the APF and like basically like tune something in a negative way to basically DDoS the cluster, like if they got into it? Or is there something that protects it, like maybe the operator goes and overwrites it because it's part of the operator config? You see what I'm saying? I don't know if you can, I don't know if I'm asking that very well.
We leveled some level of protection. So the objects that hit by default, the bootstrap objects, they have an annotation like auto update. So if you update them, it'll basically be overridden by our controller. But you can remove the annotation. So that means that you have to opt in to sabotage yourself. Like you cannot do it unknowingly, basically. So,
yeah, it's on purpose, right? You're there to actually do bad stuff. Okay.
Yeah.
It's easier to use it to block anything that comes from Jonny namespace. It's easier to do that.
But still,
that seems valid.
You could create like thousands of flow schemas and thousands of priority levels, and just your cluster will probably be at hose at that time, right? But that's something you're kind of opting in to do.
Gotcha.
And this is where I put my PM hat. And if you see something that on a specialized workload or something that probably we need to consider to fine tune and include, let us know, because we have seen many use cases, but there are far more, especially with the new type of workloads coming into the cluster that we might have not seen. And we want to keep updating this to have the best possible defaults for the performance. Okay, so I have to put my my PM hat on that one.
Yeah, it's awesome because like I can definitely see the benefit, right? Where like you gave the example a minute ago where it's like, oh, I want to isolate a workload to maybe debug if it's having problems, or to essentially make sure that it's got the resources that it needs to work. Like again, with all these specialized work, we're going beyond taints and tolerations and labels and match selectors and all that now, right? Now we're actually getting down into we're getting in the weeds, and we're saying, hey, look, if you've got this thing and you need it to have this amount of resources, or you need it to have this priority above, Jonny's website. Boom, here you go, and we'll isolate. We'll basically QoS you and get you what you need so you can work. That's pretty awesome.
Although to be clear, it's not. This is only for requests against the Kubernetes API server.
Yeah, the API. Yep.
And I assume the OpenShift API server is lumped.
You mean the OpenShift API server? It's an aggregated API server. So any request, so you have let's say you have image or build APIs. Those requests go through the Kube API server. So you can define flow schemas and rules based on that. So since the OpenShift API server is not accessed directly, and all requests go through Kube API server, I think you're already getting the protection from there. So we don't think that there's a need to configure priority and fairness for the aggregated servers, because you're kind of covered by the API server.
Yeah. So here's something I've never thought about before. The OpenShift API server is a CRD in the same way that any other operator is. It's just not. I don't think it's an operator in this traditional sense.
OpenShift API server. We have some actual APIs, like OpenShift specific APIs. I think they're actual like types like pod or config map, not just CRD. I think we have some. I think route is a CRD today, but I think builds and like image streams, those are actual API objects, like config map, but are managed by OpenShift API server exclusively. So
the template and all of those. But
yes, yeah,
it is an aggregate API or API aggregation. I don't remember the right term, so I will correct me here. Which is a different way to present or extend the Kubernetes API, which was before CRD existed.
Yes, yeah,
okay,
yeah. So this is an like actual API server sitting behind the Kube API server. And if you create a template or a deployment config, that request is received by the Kube API server, and the Kube API server knows that this request should be managed by OpenShift API server, and then it forwards it to the OpenShift API server. OpenShift API server like takes care of it, stores in SCD, and then returns the result back to the Kube API server, and the Kube API server forwards the response back to the caller.
Interesting. I've actually been curious about that for a long time. Because, and here I can show the world what I'm thinking here. So if we look at a cluster, so if I do OC get or OC API dash resources, I think, and then I grep for OpenShift, it comes back with all of these things, right? So security.openshift.io and tuned.openshift.io, and all of these are served by, as far as I understand, the OpenShift API server.
Yep. And now I think we have one more OpenShift. OAuth API server. So I think the security objects, the OAuth objects, are actually served by that aggregated API server.
Oh yeah.
Yeah, you see OAuth.OpenShift.
Yeah.
Yeah.
Yeah. Interesting.
Mm-hmm.
That. Oh yeah, and see, yeah, interesting. I see. You learn something new every day.
It's impossible to know everything about OpenShift. We have so much capabilities, and this is transparent to the user. The user does not need to know those abstractions that we have. I mean, those details that we have, because they just see the Kube API. That's the beauty of it.
Same every day, even like us, we learn new things. It's just Kubernetes is so complex and so many layers, right? Every day you learn, and that's why it makes the job so interesting.
So I want to be a little cognizant of time. Abu, I know you still had some slides that you wanted to talk about. I'll turn those back on. But I don't. Is there? And I may be skipping ahead here. Are there things that we should be aware of or consider? With the API priority and fairness. Are there, in particular, I'm thinking, are there times when we should go in and adjust these values, or when we should create a new priority or flow schema or anything like that? Or is this one of those, like, when things are breaking, this is one of the levers you can pull in order to keep the cluster operational until a fix is implemented, whether that's
Sometimes you can tweak with the values if you think that would like avoid like a cluster degradation, right? Or from the cluster going to like a being unusable. We are introducing a concept called jailing. So like you can say that this priority level is going to have 0 concurrency share. That means nothing. That means all requests coming from this component will be basically rejected, right? You can, like, if you are in a cluster admin, you're seeing that you have a component that is actually, once you do the investigation, that component is sending requests to the API server, and that's causing the API server to be degraded, right? You can I think create at least temporarily a flow schema to classify those requests, and then give it like a dedicated priority level to improve things. Permanently, if you want to add like flow schema and priority level objects for your cluster, I would say please talk to your, if you're like an OpenShift user, talk to your account rep so that you can discuss it and then go through the pros and cons, right, before you do that. Something that you want to do permanently.
Yeah. Okay. I was thinking that would probably be the answer, so it's good to know for sure. Because this is one of those things where if we do our job correctly, you should never know that anything is happening at all.
Yeah. And we do try to tweak the bootstrap objects from release to release. If a reporter, like, if we have a report that this some issues, and then we see that, maybe we can tweak it, and then this will improve it, right, based on some tests. We do actually revise the bootstrap objects from time to time to make things more improved.
Okay. And so for our audience, if you have any questions, if anything has come to your mind, please don't hesitate to put those into chat as we kind of close out here over the next few minutes. William sent us a message here on the back end saying that he had to drop to go to a customer meeting. So I feel like when you have the PM for the API and etcd on the call, that means something is horribly broken, but let's hope not. So Abu, I don't know, and my apologies, I haven't seen what's next in your slides, so I don't know what else is here.
If like a couple of minutes maybe, I think. So we talked about the flow, and then each flow schema has a corresponding priority level, right? And the priority level defines whether the request will be queued or not, right? So basically, you can define in a priority level object, you can say, I want, like, you can specify the number of queues you want, right? What is the maximum length of each queue, right? And the hand size for the shuffle sharding. So we use shuffle sharding to allocate the queues. For example, you have flow schema. A request comes in. The request is matched to the flow schema, and the flow schema points to a priority level, and that priority level has, let's say, 128 queues. So where do we set? Where do we put which queue do we select for this request, right? So we use shuffle sharding for that, so that we have a better isolation, right? And once the request is unqueued, right, and the scheduler will basically scan the queues and look to find the first find the the request that should be scheduled at this moment, and pop it up from the queue, and then actually allow it to be executed.
And this is a bit of a tangential question. I know, so by default we have, I believe, 2 or 3, I think 3 instances of the API server, one on each control plane node.
Yes.
Do those coordinate with each other, or does each one have its own set of queues?
Each one has its own set of queues. Yeah. the APIs are global. So each API server, when it loads, it scans through the basically there's a controller that keeps watch on these objects, right, and then reloads its configuration. But the in-memory configuration is is local to the API server instance.
Okay, so it is impossible where you could have one that's overloaded, one that's rejecting requests, and the client resubmits and it gets a different API server that is able to service the request.
Yes.
Yeah, this is all, the API server is one of those things. It's so fundamental and so critical to every aspect, right? And yet, at least me, I've historically treated it as it's just a thing that's there that magically works, and it is generally a proxy to etcd information, and I think clearly that's not true. It's its own complex and unique beast of all the different things that are going on. I also think that it's a testament to your work and the rest of the team, both in Red Hat upstream, right, all of the groups that contribute to it, that you generally don't have to think about it a whole lot. Right. It does what it's supposed to. And yeah, it consumes resources. We've talked about resource optimization for the API server and stuff like that, but it generally just does what it needs to do. And, that's one of those, that's a great feat of engineering.
Thank you. Yeah.
All right. Well, is there anything else that you wanted to talk about or bring up, Abu?
No, I think that's at a high level is what, unless there's some questions we can answer, but.
No, I don't think so. I'll say I will remind everyone that you do have a KubeCon session. So if you're going to be at KubeCon Paris in another month and change, be sure to check out that session. You can also, I'm sure, as they usually do, those sessions get posted online sometime after that. So you can always go back and look at those. I'm looking here. I can see in the upper right corner that these slides are from 2021
yes.
KubeCon. So as always, you are, for any of our audience members, you're welcome to reach out to Jonny and I. We are happy to broker conversations over and, help answer questions and stuff like that as much as we can. So anything that comes up, sorry for the dog shaking, anything that comes up, please don't hesitate to reach out to us, whether it's today here live or, anytime you happen to be watching this. Jonny, we recently we got a question from back in like episode 30 something. You remember that? I don't remember which one that was.
I have no. I remember it, but I don't remember the question.
It was before you were even co-host with me, right? It was from so long ago. I didn't realize people watched the streams from that far back. So thank you. That's going back to it's going back at least 3.5 years, maybe. We started in I think July or August of 2020. So it's been a minute. Anyways, thank you to Abu. We greatly appreciate you coming on. William, who's not here, appreciate him being on too. But this has been very informational. I've learned a tremendous amount, and it's answered a number of questions that I've had and honestly didn't know who to ask. Just clarification of how things work and what this means, and of course, learning new stuff along the way. So thank you.
Thank you. Take care.
Yeah. And with that, Jonny, while I figure out what buttons I'm clicking, I will hand over to you for last words.
Yeah, Abu, thank you very much. And William, if you're listening, thank you very much for reaching out to us and bringing this up as a topic. I definitely did not think beyond, like, I was very much in Team Sully on the API server, like, oh, it's there, it's a thing, it's cool. Like, I don't have to touch it, so we're all good. So I learned a ton today. So I really appreciate you taking the time to sit with us and explain it to us. So thank you very much.
Absolutely, happy to be here.
All right, we will see you all next week. Thank you.
Take care. Bye-bye.